most of us did fine for numbers 1 through 4. There were some issues. For the parallel ones, make sure you're doing the same slope. So that could be y equals 5 over 2x. Pick any y-intercept that isn't 3, and you were fine. If you changed your slope, that's not what you're supposed to do for 1 and 2. So I'm going to leave mine like that. You could have whatever y-intercept you want, just not positive 3. Yes. You wrote y equals 5 over 2x. I'll have to look at it. For this one, the same slope meaning it's also a y equals. So pick some other number that's not negative 4. As long as it was not negative 4, that was fine. If you changed it to x, that was not. Questions on that one? 3 and 4, you have to flip the slope, and if it was negative, make it positive. So y equals 4 over 3x. Whatever y-intercept you want, it can be the same, it can be different, it doesn't matter. And then same thing for 4, flip the slope, so not just make it negative, but it has to be, this is over 1, so that would be negative 1/6, and then pick whatever y-intercept you want. Then for these, you have to use point slope for one of the parallel and one of the perpendicular. So I'll do these two in point slope. This one you won't need that, and then that one using slope intercept form. So parallel, we're using the same slope. We don't need that y-intercept. You can cross it out. So this would be y minus 1 equals negative 3 over 2 times x minus 2. If you did point slope on this one. You would distribute the negative 3 halves. The negatives would cancel, so would the 2's, leaving negative 3 over 2x plus 3, and then add 1 on both sides. So that y equals negative 3 over 2x plus 4 was your final equation there. If you're checking yourself in Desmos, remember to put that final equation in, put your original in, see are those parallel lines, but you still need to show that one. Nathan.
Where'd you minus
From here, from the point. This is always y minus. Okay. In number 6, if we're using our slope intercept, still parallel, so we're going to use that same slope, negative 3. Don't need the y-intercept. And in slope intercept form, that would be negative 4 equals negative 3 times 5 plus b. Multiply negative 3 and 5. And then add 15. So that y equals negative 3x plus 11 was that final equation. Some of us got 11, but like a negative, or maybe we got a positive 15. Just make sure if you were using point slope that you did that you changed it to a plus and then distributed. Eric?
I didn't ask you for number 5, but for my final equation, I got x minus 2. The minus is circled. How did we get that into a positive?
Oh, because the negatives canceled. So if you didn't have that negative out front, then your negatives wouldn't have canceled. For number 7, using point slope again, if it's perpendicular, you have to change the slope first. So that should be positive 1/4. And then in that slope intercept point slope, that'd be y minus 5 equals 1/4 times x minus 4. Where if I distribute that, y minus 5 equals 1/4 x minus 1. And add 5 on both sides. so that that final equation is y equals 1/4 x plus 1. Questions on that one? And the last one. This has an x equals. The slope of that is undefined. If I need something that's perpendicular to that, I need something that has a slope of 0. So you could do one of two things. You could remember your Hoyle-Bucks. Horizontal lines have 0 slope and are y equals. So if I have a y equal, I look at my y value, and that would be my equation. Or you could set up your slope-intercept or point slope. Either or would be fine. So let's say I did slope-intercept here. With my 0 slope, this would be 2 equals 0 times 2 plus b. Well, this is just going to be 0, which means b is 2. And if I put that into the equation, my slope is 0. I don't have an x. So this I'd have to get rid of. I can't have 0x that is just 0. So you could do the work for it, but for undefined slope, you could not. Questions on that? That last one, you had to write the equation of the original graph. So some of us got these numbers but forgot the negative here. So this should have been y equals negative 3x plus 2 for the original, because we're going down and to the right or up and to the left. And then your parallel would be something with the same slope and a different y-intercept. Pick whatever you want, just not 2. And then the perpendicular, you would take that slope and flip it and make it positive. And then pick whatever y-intercept you want. So all the other ones were worth 1 point. This was worth 3 if you got all 3.
How'd you find the original?
Look at the y-intercept. Find another point that crosses the grid lines. And then count down the number. Other questions? Let's go through the word problems. So in number 10, I'm going to label everything first. 1750 was M, 35 was E. This is going to be our X, and we'll count that in a second. And then our total cost was Y. There was argument of how many hours that would be. It should have been 5.5. So if you got 6.5, your answer and works were just a little off. But then most of you set up that equation correctly. Y equals 17.5 times 5.5 plus 35. And then you could have multiplied, then added, or put that all in at the same time. To get a total of $131.25. Questions on that? So that was, did you get the equation correct? Did you get the solution correct? Yes.
So for the hours, you would have just counted 10.
From 9 to 10 is 1, 11, 12, 1, 2, and then a half, yes. Right. In 11, we have M, we have an X, and we have a Y. But because we're not given a b, we're going to use our point slope in this one. So this would be x1 and y1, so that we can create an equation to find the cost to rent shoes. So y minus 47 equals 595 times x minus 7. Distribute the 595. And add 47 to both sides. So for your equation, I accepted if you put in your original, or if you put in that final, so either or. And then your solution, if we were looking for the cost to rent shoes, that was your B. Now, some of you were getting answers that were really high. If you went back and thought about this, you only have $47. So if you got something more than that, that should have told you something's off. Also, if you got something really expensive, if you haven't went bowling, that's one thing. But if you've gone, shoes don't usually cost more than $10, if that. So keep those things in mind. These are real life type of problems. Do you have any questions about that one before we move on? Number 12 had a bunch of work that you needed to do, because in this one we were given an x and a y and another x and another y, which means we don't have our slope or our y-intercept, so we had to find our slope first by doing 1268 minus 1172 over 1000 minus 850. Subtract those, I think it was 96 over 150. Which was like 16/25 or 0.64. Then you had to use your point slope using one of those points. It didn't matter, so let's say I use 1000 and 1268. Then I would start solving for my equation. Y minus 1628 equals 0.64x minus 640. And I would add 1628 on both sides. I don't remember what that was. Sorry, I mixed those numbers up just then. So for your equation, it was either this one, the other point, or this. Either of those three you could have put in the equation. And then your solution, you still have to do one more thing. Find the monthly rent for a 1,200 square foot office. So if I put 1,200 in for X, that would give me my solution. Which was $13.96. So the 3 points in that work. Did you find the slope? did you set up your equation and start finding the work to find your actual y equals mx plus b equation? And then did you put 1200 in to get your final solution? What questions do we have about that? We'll do that last one when we come back, and then I'll explain the different project options for you, and then you guys can decide. Really quick, for this last one, this is comparing two different things, nickels and dimes. So this should have been your ax plus by equals c. It doesn't matter which one was a. So let's say I made that 0.05 for the nickels, and b the 0.10 for the dimes. Then I would set this up 0.05 x, I don't know the number of nickels, plus 0.10, I know the number of dimes, 46, and I know the total. Some of us, as we set this up, didn't put all the decimal places, so we put 0.5 instead of 0.05. Make sure you're putting 0.05 for your nickels, and 0.10 for your dimes, not 10. And then if we multiply this out, we have 0.05x plus 4.6 equals 5.45. Subtract 4.6 on both sides. And then divide each side by 0.05. So if you were getting some large number, that could have told you I'm missing decimal somewhere. And then your final answer should have been 17 nickels. So your equation would have been this one, 0.5x plus 0.10 times 46 equals 5.45, and that would have been your solution. Questions on that? Okay. So for the project, there are different options. If you did the project for the last unit, you have a continuation part where you're going to continue doing that same sort of thing. I'm going to have this out, but I didn't. So if you were doing the project from last time, you're going to use your slopes from that last project on this and follow those directions. Look for the y-intercept, the slopes to make equations, and then continue making lines. If you did not do that project last time, another project option is like the Unit 1 project, where you're creating equations for the parallel and perpendicular lines, and then creating scenarios for the word problems. If you did the project and still want to take the test, that's fine. If you did the last unit project, that project is only for the parallel and perpendicular lines, so you would still have to take the test part of the word problems. So you have different options.